to walk through mathematics called BODMAS. And since that time, mathematics is not something you memorize. It is something you walk through using basic logic. And with that perspective, mathematics did not scare me. Mathematics became something like a hobby. And when I got into Queen's College in 1958, during religious knowledge class as well as history class, I would be solving mathematics problem instead of listening to Miss Reed, who was my religious knowledge teacher, and Mr. Callahan, who was my history teacher. They were not happy that I was ignoring their subject and choosing mathematics. I chose mathematics because mathematics was exciting to me. It was something that I could walk through using logic, simple logic. But in Nigeria, mathematics is one of the bane of the society, where majority of students fail just as they fail English. And so today, I give to you Professor Nkechi Agu, who, like me, when she came to Akure, turned mathematics into a fun project for all of us in the Nigerian Women in Agricultural Research for Development, as well as the various staff of the Oba of Akure, the Deji of Akure, because she used her knowledge to show how mathematical knowledge was used logically for security of the Deji's compound. And since that time, I have been in love with Professor Agu, who has used the profiles of some of our members to make it mathematically interesting. And so I'm hoping that the 20 people that have joined us would find mathematics an interesting subject. And we hope that it is the beginning of a relationship, an interactive work that would make mathematics fun for our youths in our Nigerian institutions, starting from now onward. So, Professor Agu, I hand over 20 participants who have joined our virtual program this afternoon. I know it's 9:06 in the morning in New York. So I am sure you are wide-eyed, you are eagle-eyed, you are not tired, so that you can make the 20, we are now 22 participants on this virtual program, excited to teach and use mathematics as a fun subject. Over to you, ma'am.
Good afternoon, everybody. Good afternoon and good morning to me. I'm excited to be here and I hope you are too. Before I go into the presentation, I want to say a little bit about why mathematics and culture. I always give this story that when I was at University of Nigeria in Nsukka studying mathematics, my abstract algebra professor was teaching us abstract algebra concepts using examples of snowflakes. I had never seen snow because I'd never been to Europe or to America at the time when it was snowing. And so some of those things she was teaching us with snowflakes did not resonate as much. And it was when I came to University of Connecticut that I realized that some of the things that I was learning with snowflakes could have been taught with me using a local Adire material or Accra material, and it would have made better sense. And that was what started my journey into mathematics and culture. And before we go further, I just want to show you what I have here, which is a set of cowrie shells that is ancient money that can be used to teach arithmetic. And in fact, one of the activities that we have in there is the cowrie shells. And also to relate people even to their culture, because the cowrie was used for trading commerce in all over Africa, and also to buy and sell slaves, which is a horrible part of the world's history, the Atlantic and Transmeridian slave trading, which traded a lot of us black people all over the world, where we are today. So I will ask Erin to put up the slides. I was recently gave a presentation by the Joint British Mathematics Society at their Black Heroes in for Mathematics conference, and I have asked for the slides to be put up so that I can go through that presentation. Uh, and people can always go back to the Erin will share the link where the presentation is, because we may not be able to hear exactly what I said, so I'm going to be speaking over the slides this time around. So, Mrs. Bello, can you share your screen? Erin, can you share your screen? Okay. It's the title, of course, here is Mathematical Storytelling, Fostering Creativity, Innovation, Gender Equity, Cultural Awareness, and Entrepreneurship. That's the title of my presentation for Black Heroes. So when you get the link, that is the title you should look for. Next slide, please. And basically, what I spoke about is what I consider to be mathematical storytelling. I use my own mathematical story and link activities in mathematics that can be done with it, which is to tell everybody that if you look at your biography, you can find mathematical stories to tell. And I also discussed the Carnegie Africa Diaspora Fellowship Project, which Professor Williams told you about, that took place in Akure, and now it is, can you go back to the last slide? And now it is continuing um, with the National Mathematical Center. So basically, mathematical storytelling is an innovative tool, procedure. It uses the tools of mathematics, concepts, theories, indigenous knowledge systems, cultural artifacts such as games, textiles, architecture, to tell stories about people and communities in a manner that will foster creativity, innovation, cultural awareness, gender equity, and entrepreneurship. And I strongly believe that if we apply mathematical storytelling into our teaching, not only will our students be more excited to study mathematics, they will also be strengthened in their culture and their history. They will develop a pride in it, and they will also see how our ancestors in the past did things, and they will be able to innovate better and become small business entrepreneurs even early if they so wish, as well as they will learn about the lives of successful women in science, technology, engineering, and mathematics, and also rural women who are doing things that are worth emulating, such as the women in Abeokuta that are creating dire material and so on. So I will talk a little bit about my mathematical story. I am Nkechi, God's own. Nkechi in Igbo means God's own. I am represented spiritually as the feminine form of the Trinity. And the reason I say that is my first name is Nkechi, God's own, child of God. My middle name is Madonna, which is the Italian form for Mother of God. And my last name is Agwu. And if you know the meaning of Agwu, it means spirit, the spirit of divination and creativity. So I look at myself as a feminine form of the Trinity, three in one. I am personalized. Can you go back to the previous slide? Can we go back to the previous slide? Uh, Go back to the previous slide. Or you have it on slideshow. Okay, I am personalized mathematically as the infinite number of concentric equilateral triangles and the infinite triangular sequence. And basically, when I visited the Deji's Palace in Akure, one of the things that I observed in the coronation hall is that the columns had lots of concentric triangles, equilateral triangles there. And I'm hoping that the next time I visit, maybe I'll be able to ask more questions as to whether there is some type of symbolism related to those equilateral triangles, similar triangles that are stacked one on top of each other. Like George Cantor of set theory, I am interested in how mathematics reveals the existence of God as the absolute infinite. And in fact, in the Deji's palace, they have a pond there. And that pond, they say, never runs dry and never overflows, no matter how you fill it. So it is like an infinite sequence of water, flowing water in the Deji's palace. So, um, to know me, you need to understand the properties of the three-sided polygon and the infinite sequence of that is a triangular sequence on the third diagonal of Pascal's triangle. So I'm relating my own biography or how I see my identity to some mathematical aspects, which is the arithmetic triangle, Pascal's triangle. And basically, just with this story um, about myself, one can begin to ask students to do mathematical problems that may interest them, like telling them to construct equilateral triangles, similar equilateral triangles, like is found on the Deji's palace in the coronation hall, or like I identify with in my own name, my name being Nkechi, my father's name being Jacob, and my son's name being Jacob. When I write, because I love to write fiction, my fictional name is Umma Jacob. So I call myself a triangle. A triangle of Jacobs is part of my identity. Then you could also, since I have said that I look at myself as an infinite triangular sequence, you can also ask students in a discrete math class or a class where you're teaching calculus 3 to find the sum of that infinite triangular sequence by induction, or to prove that the sum is the tetrahedral number that is given there. You could also ask them to create sequences where you give them values for n. N could be 1, n could be 10, and so on, powers of 10, or you can do powers of 2 and so on, and make it exciting. So through the story of somebody, you can you can teach mathematics. You just have to look at those things in the person's life that could relate to certain things in mathematics. Next slide, please. The next is on So what is the Carnegie African Diaspora Fellowship Project that brought my work, or the work I was doing, to the forefront, got me to Akure, Federal University of Akure, and now at the National Mathematical Center. That the title of that project is Culture, History, Women's Stories, Framework for Capacity Building in Science, Technology, Engineering, Mathematics, and STEM-related fields, and for fostering entrepreneurship education. And basically, it is a collaboration between an Africa diaspora mathematician, who was myself, and an African institution. And the first institution that I collaborated with was the Federal University of Technology, Akura, the Center for Gender Issues in Science and Technology, where I was introduced to NIWAD, which is the Nigerian Women in Agricultural Research for Development, and where we used the stories of some of these women to develop different types of mathematical activities that people can use in teaching in their classroom various concepts. With the National Mathematical Center, what we have been doing now is to go to different uh, regions of Nigeria and interview the people that are the custodians of the culture, like the elders, the elders, and so on, to learn more about their indigenous mathematical knowledge system, and to construct curricular activities that can be used for teaching different concepts. And we already have a book that we have written or authored that has a series of these activities in them. With regard to the capacity building for women, we have been using the stories of successful women. We have used stories of women in NIWAD and stories of the Nigerian women in mathematics and other successful Nigerian women to write their biography, just like you saw me talk about my identity, and to hopefully to foster a young girl child into the sciences, because we are really underrepresented in the sciences. There are less than 1% of the PhDs is African women in STEM. In fact, in the engineering fields, it is even the worst. Yeah. So next slide, please. Okay. Here you see me with 7 Indebele dolls, but it could be dolls from any ethnicity in Africa. Uh, these are not just dolls per se. What has been done here was that students had to read the life of a woman, an IWAD woman. They had to read her biography, and then the doll that was created represents the woman who they read the biography, and whatever they decorated that doll with is vertex edge graphs taken out of the life of the woman. So if the woman gave you her educational part in her biography, you can you will see on the door that educational part. And they were also learning about coloring mathematically. So they would color whatever that graph they pulled out of her life, they would color that graph for its chromatic number. The chromatic number being the minimum number of colors that you can use on any graph so that no two neighbors share the same color. So that is one of the things that the women that they had to do. In creating those dolls, they are also learning about vertex edge graphs, how to color mathematically, how to cipher because they had to put color codes. They are also learning coding, and at the same time, they are learning how to create something that they could turn into a business. Because in fact, if you go on the website and you click on Indebele dolls, you will see that some of those dolls cost a whole bunch of money. So they are learning a skill at the same time. That's where the entrepreneurship comes out. And it doesn't have to be Indebele dolls. It could be any other thing that is a cultural artifact to us in Africa that you can replicate the same activity with. But why do I have 7 dolls there? It's because 7 is a significant number in most of our African cultures. For the Maori people in Abuja, 7 represents a kingship cycle. And each time a king has gone through 7 years, he has gone through one cycle. By the time he does 14 years, it's a second cycle. 21 years is a third cycle. So the Maori people have an indigenous knowledge system where they understand arithmetic sequences because it is replicated in their kingship cycle, which is an arithmetic sequence with common difference 7 and first term 7. Next slide, please. So these 7 dolls represent 7 Naiwad women, and these dolls were created by students in my discrete math class. Next slide. Click on it. I think it will open. Give it time. I think the slide that has it, give it a few minutes because I saw it opened when we were testing. Just click on it. Yes, right there. Oh, it's going back to the previous slide. If we can't get it to open, where it has the bar at the bottom, see whether you can click on it. At the bottom, yes, right there, where you saw that small arrow at the bottom, right there, click on it. Okay, if we can get there, right there. If we can get it to open, I will just say a few things as to what is in there. Sometime in 2018, we had a workshop here in the US with the Drama Institute, since I also founded an organization called Chistem Toys, uh, both in Nigeria as well as in the US. And basically, what it does is to do
Prof.
exactly what.
Professor
Um,
Adu,
yes.
please could you speak up a little bit? It looks as if they can't hear you properly.
Okay.
Raise your voice a bit.
What I'm saying,
Thank
can
you.
people hear me? Is that better? Is it better?
I think it's better now. Just raise it a little.
Okay. What I said is in this slide that okay, it has opened. So so what is going on here is that I said that some time ago we had a workshop in 2018, an Indebele Dolls mathematical storytelling workshop, where we brought some high school and middle school students to learn the lives of Naiwad women. They selected the women that they wanted to read about and to create dolls that replicated them, that had vertex edge graphs, had ciphers, and other things that they pulled out of the women's lives. So what you see there are the participants of the workshop, the dolls they created. They spoke about each of the dolls and why they chose that particular Naiwad woman to or women, because they created multiple dolls um, to 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 write about or to construct. And some of their dolls were so beautiful. And at the end of the workshop, we had a closing ceremony where we invited people from the outside to hear what the girls were able to accomplish and hear what they learned about how they had been empowered mathematically and in other ways um, through this workshop. And this is one of the girls explaining what what is the decoration she has on the doll, the mathematical decoration that is on the doll, and what those things represent. And it was actually covered in the news both before the workshop and after the workshop. Okay, we can move to the next slide. Can move ahead. It tells you that she put the family tree. Uh, she did a complex graph about the work that the woman had and her relationships and other things. And when you do it this way, you get students to take pride in their cultural heritage. Now we go to some of the activities that were developed around Naiwad women. This is of Dr. Joy when she was in one of the villages in Anambra State where the women uh, are farmers. As you know, farming is very important. Farming uh, is a very important occupation for our people, particularly the women. At least where I come from in Alai, a lot of women that are primarily doing the farming work these days. And here she took a picture. And this is to help students understand that anytime you have a picture, that is a map. And anytime you have a map, that map can be associated with a network, a vertex edge graph. So you're now teaching students about network systems, which are very important in transportation engineering and in and in urban planning and so on. When you see that uh, 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 when you see that you have a traffic jam somewhere, it is because that network has a lot of roads sometimes leading into it. So the network systems is very important and the students learn it early if they are learning it in the context of doing things that relate to their culture and that are exciting. So the questions there have to do with network systems and also color coding. Next slide, please. So anytime, and in fact, here you're teaching them that a picture is not just a picture. A picture can be translated to a network system. Next slide. This is a slide also to teach them about coding. They are introduced to the Pythagorean cipher, which is one of the ancient ciphers that was developed by the Pythagoreans, which we all know. Many people are familiar with the Pythagoras uh, theorem and so on. And here they have the cipher and they begin to learn about how to code, code the person's name using Pythagorean cipher or to decode something sent in Pythagorean cipher, and they are doing it in the context of reading the life of a woman. So whatever they are coding or decoding will relate to that something from the woman's life. And at the same time, they are learning about a woman that they probably would never have known and getting maybe inspired by her work. Next slide, please. And then they, after doing it with Pythagorean cipher, they may do it also with the Caesar cipher, which was used for war by the Romans, or they could do it with any of our African ciphers, because we are gradually losing African ciphers. Like the talking drum is a cipher by the Yoruba people, but I don't think that anybody has tried to put in words what those beats translates to, so that students can learn about them mathematically. So we have a lot of ciphers in African cultures that we need to begin to document, so that our students can learn coding also from the perspective of their culture. Here we we have women of Nile, and it's not just teaching them mathematics, we're also teaching them important things about life. The first person, uh, Buki, works with the Center to End Genocide and Crimes Against Humanity. So here they learn the important issue about gender. Genocide is not a good thing, and it's a crime against humanity. In fact, we have a lot of that going on in Nigeria today. Every other day you hear about either Fulani herdsmen or Boko Haram having killed a whole bunch of people. Those are acts of genocide and crimes against humanity. And it is important that our children learn those things early, so that they don't be the one to commit it, or they know what to do. The other lady is Dr. Binta. Is also, her story is important because it is a story about the lives of young girls in the northern part, where they were not encouraged to go to school or to get educated, and she tells her story related to that. Had it not been that her parents had vision, she would not be where she was, because they tried to brainwash her against education. Now, the activities that were developed around them relate to the cowrie, traditional money, as well as relate to farming, and relate to also learning how to help people who are less fortunate um, than you. And so, in the context of people, girls doing the work, they are also learning how to give to people who are less fortunate than them. Next slide, please. So you have a whole bunch of activities we developed here, related to cowries, and to teach about rate, proportion, percentages, and also in the context of learning about farming and learning how to give to others. And when we start to teach mathematics this way, number one, what it does is that it brings in educational equity, because schools that are not do not have resources don't have to worry themselves too much about resources, because you're using materials or you're using tools that do not cost money. for them to learn the context. Those dolls that were created out of purely recycled materials, water bottle, old clothes, buttons, and so on. So things that don't cost money. So you are leveling the playing field between the schools that have and the schools that do not have. When you start to teach from a cultural perspective where people have those things in their house, so it is easy for them to learn about. Like I talked of my algebra concept that I learned, which I could have learned using Adire. I have Adire in my house, or I have Akwete cloth in my house. So I'm not spending money to buy something because it already exists in my home. Next slide, please. Okay. Before I go into acknowledgement, there's something I wanted to say, and we go back to the Deji's Palace. How mathematics was used in warfare in in Akure Kingdom. Unfortunately, Nigeria has not yet begun to really harness all the things it could do with regard to tourism. In the ancient Akure kingdom, they protected the kingdom by drilling a dredge. One of the Dejis protected the kingdom by drilling a dredge all around the kingdom, whereby you could only enter the kingdom there were only two entrances into the kingdom, and that dredge really protected the kingdom. And it relates to mathematics because he used measurements to ensure the depth of the the dredge was deep enough that if anybody tried to come through the dredge, they will fall in there and die. So that's one of the things about warfare engineering stuff. Even one of the Oba's palace in Benin, if you study the vertex edge graph of that palace, you will learn a lot about techniques of warfare and how the Oba was protected against the enemy. Because before you can get to where the Oba's room is, you have got to pass through a spiritual deity room, and not many people will want to even enter where they think that the spirit will get at them. And then you find out that the Oba, to entry into the Oba's room, there were so many entrances, which makes it hard for you to capture him because he has easy means of escape. Because in order to capture him, you have to block off all of those entrances. So these are some of the things that ancient uh, uh, traditions can teach students a whole bunch of things with regard to how to innovate or to create or to learn about certain skills or coding or what is important to secure yourself even as you build your house. uh, uh, you can learn a lot of things from the urban those ancient architectural houses, what is important in terms of how you secure your house. Recently, I had one of my pastors who built his house, and then he built his wall around the house, and he has only one entrance. And I had to tell him, I said, when you have time, break up a side of your wall and create a second entrance. I said, because if you have only one entrance, it means that you can get blocked in that entrance. Either if people who want to endanger your life are coming for you, All they have to do is block off that entrance and none of you can escape. I said if you have a fire or what have you, you have no escape route if that entrance is blocked off, and so on. So there's a lot that we can learn mathematically from the ways our people built houses in the past, even the mud houses, and how they protected their villages in the past. And that was a close of my presentation. And like I said here, as you can see, there are many institutions that help to bring it to this level, of which PANAFRAG is one of them, because we have been sharing what we do at the Math and Culture PANAFRAG workshops since 2014. That was when we started. Thank you.
Thank you.
There's one last slide that I need to discuss. Go to the last slide. Mm. Move to the last slide. Okay. The last slide is more or less to tell you that we need to, or to emphasize that we have many things in our culture that will teach mathematics, that our mathematical tradition is all around us. It's in our clothing, our spirituality, our architecture, our warfare, our art, our music, our food, our healing traditions, the work our grandmothers, mothers, and daughters do. This is all mathematical if we care to look deeply. And so basically, what we have in Africa, even though that people have not documented it the way the Europeans have documented it. So our curriculum is a silent curriculum for now, until more of you go out there and look at what we have inside us and begin to translate it mathematically. So I hope that this will be an inspiration to some of us to look at what we have. Thank you.
Thank you very much, Agu. We have two questions. The first question is, does this apply to secondary school mathematics? Does
Yes.
this apply to secondary school mathematics?
Yes. Different concepts in your secondary school mathematics. I just showed you people the activity on the cowrie shells, which we use for rates, proportions, and you can use it to teach rates, proportions. You can use it to teach people how to convert, because we have formula conversions when in science. In science, you can convert from Celsius to Fahrenheit. That's a formula. The same thing with cowrie shells. You can do rate conversion. They tell you how many shells make a tie, how many make this thing, and then you teaching students about conversion rates. So you can develop activities for any class, any mathematics class, right from kindergarten up to university.
The second question is, how can we use the cowries to teach proportion in practical terms?
Okay, they can bring their, they can, hold on. They can bring their cowrie. I don't know whether you're seeing it. They can bring it to the class, and you can, they together with something else that might even be traditional, and you can do the commercial thing that people did in the past, which is, okay, with 10 cowries you can buy one phone with 10 cowries. Okay, so how many cowries would I need for 20 phones or one pencil? you can, if I'm selling a pencil and you have got to pay with 3 cowries for it, how many pencils can you buy if you had 100 cowries?
Thank you very
And
much.
it doesn't have to be cowries, it could even be manillas or some other type of traditional money, because in the past too, manillas were used also for money.
Thank you very much. We've dropped about 4 people. We are down to 27 participants from 32. But what on the things that I would want to say is that you have shown that in the practical sense, that the teaching of mathematics can use what we have around us, not use foreign things to teach
Yes.
mathematics. Because as you said, when you were at UNN, your teacher was using snowflakes. Nigeria would never have snowflakes. You only saw snowflakes when you got to New York or when you were at Connecticut, where you and I are both alumni. Okay?
Yeah.
But right here in Nigeria, what you are trying to tell the 27 people who are still on this webinar is that mathematics should not be what we call in Yoruba, Beru, Sole.
Yes.
It has to be logical. And the way it can be logical is using practical examples to convert into numbers,
Yes.
and then use that numbers to find out what the answers are. Like you said, if you say 10 calories would buy you 1 mobile phone, how many calories do you need to buy 10 times 20, right? That has no reason to memorize.
Yeah.
It is logic
Mm.
in that you have conversion of the cost of 1 mobile phone is equivalent to 10 calories. So how many calories do you need to buy 20 mobile phones for your market? We have Alaji Jimo online. Alaji, are you online? Hello, Alaji.
We lost Alaji again, ma.
Oh,
Unfortunately, he's trying to
Guess
get
we can
in.
continue. We can continue chatting.
yeah. But those are just the 2 questions that were asked. I don't know. Mrs. Bello, is anybody putting up their hand for more questions?
Yes. No, okay. I think there's one question in the Q&A. So somebody said, what can all the stakeholders do in order to apply all these methods, looking at the perspective of overwhelming number learners in the classrooms?
Can
Did you?
you repeat the question?
What can all the stakeholders do in order to apply all these methods, looking at the perspective of the overwhelming number learners in the classrooms?
I think even if you have a crowded classroom, you can still teach this way, just the same way you teach them without their traditional skills. For one thing, you can try to use group learning when you're using the traditional um, items. You can ask them to bring in maybe whatever they have in their house that could relate to what you want to teach. So let us say you wanted to teach about coding. We all know that the talking drum is a Yoruba cipher. There's also one leaf that they used in the past to send messages. You could ask them, you could ask your students to bring those in and to now expand upon those codes to create their own codes. I don't know how many people know how to play talking drum these days anymore. So we are gradually losing uh, what we know. Even the Yoruba method of counting uh, is a very strong method because it reinforces subtraction, and we all know how elementary students find it difficult to do subtraction, but yet we are not using a traditional numerical methods to teach arithmetic, when some of our traditions have strong methods of teaching addition, subtraction, multiplication, and division.
Well,
For
Professor,
instance,
you
for
have
in-
just raised you have just raised a very valid question. And that's why I was looking for Alaji Jimo. You see, in Nigeria, we want to follow the British system because we are using the British curricula for our teaching. We are not teaching outside of the box. And so what you are trying to tell these, we are now back up to 30 participants. What you are now trying to tell these 30 participants is that the proprietors, proprietors of their schools need to be aware,
yes,
thinking outside of the box in
but
teaching mathematics by using our cultural uh, activities that could help the students not to memorize, but to quickly remember,
yes,
recall what they are being taught. And I think one of the challenge we would have as a group is to find out from all these participants the schools they have come from, for Mrs. Bello and I to visit their schools and share this new methodology in the teaching of mathematics with the proprietor or proprietors, especially those government schools in Lagos State, because they are not going to change the curriculum, okay? But if we are able to create that awareness at the school level, because, for example, the group teaching method that you brought up reduces stress on the mathematics teacher. Because what it does is that during mathematics class, the teacher can divide the classroom into smaller groups where they work in smaller groups instead of just looking at the blackboard and concentrating on the blackboard. And
yeah,
then
and
bring materials from their homes to use for their teaching. That's what you are saying.
yes, that is around them. So, for instance, you want to teach about shapes, you can ask them to bring artwork that they might have at their home, you know, clay pots or what have you. Like the Bowery clay pot can teach a lot about circular and cylindrical mathematics or spherical mathematics.
Well, another question just came
It,
in. The question said, nursery teacher can integrate all of the methods you mentioned to a nursery curriculum? That's the new question.
okay, nursery teacher, let us, what are some of the things that a nursery teacher will be teaching? They'll be teaching them how to count, right? Huh?
Yes, yes.
So in our traditional culture, we have a way of counting. You know, we have adopted the English language, and in our adoption of the English language to teach, we think that we should throw out our own language. No, some of our languages also used to teach our students how to count. So you can show them how to count in the English, and you can show them how to count in the language in that city. Let us say it is Lagos, in Yoruba, as you are showing them in English. They can even begin to see the patterns in how the Yoruba were counting. When you get up to in 20s, groups of 20s, they can begin to learn the significance. Like in Igbo land, 4 is a significant number. And if you look at the calendrical system, it teaches you modular arithmetic in 4. So these are some of the things that we need to bring back. What again are you teaching in nursery? You are teaching coloring, okay? So you can even begin to teach students about coloring mathematically, where, okay, you give them only 2 colors. You want to create a pattern made up of 2 colors, they color, and you are now teaching them indirectly what is chromatic number and what a path is. They are learning that right in nursery. They are learning shape. You give them 2 colors and just 2 colors, color.
Thank you very much. You've also brought something that is very important now, because right now in Nigeria, the new policy is that all students who are entering the universities must have one local dialect. It's either Yoruba, Igbo, Hausa, Funfude, Fulani, Ijo, Shakiri, and all of this. So you are now telling us at this webinar that even at the nursery level, the nursery school teacher can use both English to fulfill all righteousness by the proprietor, but also use the common language of that area to
Yes,
count, to
yes,
color, to divide, to add, and
yes,
things like that. So that these students from that early age are now not abandoning their native language for English, but they are using both the English language and their native language pari passu. That is
yes.
what you just answered to that question from the nursery school teacher.
And you find out that cultures that are doing this, like the Chinese and the Koreans, where they are using their own languages in the primary and secondary before turning into teaching English, are stronger in the sciences.
Yes. Yeah, I mean, China, Korea, Singapore, all the Asian countries, even India,
Yes,
they are good mathematically and in the sciences because they use their native language and they use their culture
yes,
in identifying logical reasoning. Logical reasoning is something that is missing in our
yes,
educational system. And that logical reasoning starts with mathematics.
yes. And you find it in that logical reasoning in every language. The, the language we use also teaches us to reason logically.
Well, I want to bring in Mrs. Bello to see, because it's now 3 minutes past 4, for us to see what else we need to do for us before we end, and then what would be the next item for the new year, 2021, now that we've been able to use virtual method to teach mathematics. There is another suggestion. May I suggest that the language teachers are actually persuaded, encouraged, and engaged in complementing the effort of our math teachers. I believe we can try these methods. There is nothing wrong in engaging as it concerns the traditional method. Well, we agree with Mr. Oniyide Olugbenga that there is nothing wrong with it. But then the teachers we don't want teachers to lose their jobs. We want teachers to be able to be answerable to the proprietor of the school. Because if the proprietor of the school only believes that teaching must only be in English and not any other language, this is an opportunity for us to create an awareness that for mathematics, the cultural perspective would help the students to be more accessible to learning mathematics and enjoying solving mathematical questions by using both the language of the country, which is official English, as well as the language of the community where the school is based. Mrs. Bello,
Yes, ma'am.
what time do we want to end this webinar?
We're supposed to end it at 5 because Alaji Jimo is still trying to come in to come and give us one or two things with regards teaching mathematics.
Okay.
So, but while we're still waiting for him to get in, somebody also asked another question, and
Okay.
I think Prof should be able to take that question. The person said, "Please, ma, how can we teach greater and less than for nursery two pupils?"
Greater and
Less than.
less
Mm,
than. You
For
can
nursery two. For nursery two.
yeah.
yes, you can teach it in terms of height, you getting people to stand
Ascending.
next to each other. So the taller person has a greater height, the shorter person has a lesser height. If two people have the same height, then they have equal height. So you can have students stand next to each other to teach them greater and less than. You can also use the traditional board game that is also done on the ground, Ayo, you know, because the winner is the person who has greater seeds in their storehouse. So you can use that traditional game which students play. Um, so these are some of the things you can use to teach about greater and less than. You know, you can even use the size of a water pot, the clay pot for water. The bigger one is has greater capacity. The smaller one has lesser capacity. So you're helping them understand greater than and lesser than in concrete terms. You can also use stick. You get what I'm saying? The length of sticks to to teach the concept of greater than and less than in a concrete fashion.
Wow, this is also good because then you are now having an interactive session in your
Yes,
class
yes,
because you are using physical measurement
yes.
to show greater, that's the taller, and lesser, that's the shorter. And then you can then use the signs
Mm,
to show the greater and the lesser,
lesser.
which is good. In other words, mathematics should not be quiet. Mathematics can be physical, can be exercise, can be fun,
Mm-hmm.
because that's what you are now saying. Because if you now in a nursery class, you ask the taller child and the shorter child to come to the front of the class, and you now show that by their height, the meaning of greater and lesser. So today, from what you have shown us from the webinar, we have been able to see that we can have group classwork. We can have interactive classwork. We can have the use of the English language and the use of the uh, language common in the community while
Mm.
we are teaching. We can use our uh, artwork, our clay pot, our symbols to teach mathematics. And by doing that, it becomes more fun instead of expecting the student to memorize, because that is what a lot of teachers are doing in their classroom. They expect the student to memorize instead of getting the student to find how to convert the activities into logical means.
And this is one of the things I have not been very happy with Nigerian Nollywood, because they use a lot of traditional symbolism and what have you, which each time I watch something, I see the mathematical link, but they are only using it for entertainment purposes and not even to teach. Even when they do the dancing, that the king will pick a wife from the best dancer, they are dancing, the dancers are dancing mathematically. And I would hope for a day when a Nigerian Nollywood will also be creating movies whereby that movie is actually also being used to teach mathematics.
We have another. The question says, what traditional methods can be used to explain numbers in words to children that aren't reading well? Wow, that's a good question.
You have to, again, this is where I say language. The language is also of the community is also important in using, because the child, before they get into the classroom to learn English, they are in their local community, they are learning, they know their local language. So that is the best way to reach them if they are having difficulty with the communication.
Well, the thing is that in our schools, the teachers are not supposed to use vernacular.
Well, this is something that educational stakeholders have got to move to change, for the allowing of vernacular in addition to English. You get what I'm saying? where possible, where it is needed, especially in the lower levels like nursery, elementary school level.
Well, one of the things that is now available is that you now have an app that you can use to convert various languages into your own local language. It is not the best because, for example, if somebody sent you an email in French, if you go to the language converter, which is an app, it will give you a near, not perfect, but a near translation in English. So what we need to do is create an awareness in our schools that by using vernacular, we are not disrupting the mindset of our young people to learn English, but that they are using the common language, their mother tongue, along with the official tongue, which is English. And that's what you and I found when we were at University of Connecticut. Because all the Spanish and all the Koreans and all the Polish, they were using their language, but they were converting it into English.
Yes.
Even in physics, in chemistry, in biology, the first thing is they think in their language and
Yes.
convert it into English for them to understand what the lecturer is saying in class. But we in Nigeria, we are so dogmatic about the foreign language, which is English, that we are ready to throw our own language out of the windows. And so what this webinar has brought to us today is that we need our teachers. Well, some of the teachers did not learn this even in the university or in the polytechnic. So some of them don't even know what you're talking about in terms of how you read numbers. Ọ̀kan, èjì, ẹ̀ta, ẹ̀rin, àrún, ẹ̀fà, èje, ẹ̀jọ, ẹ̀sán, ẹ̀wá. Some of them don't know this. All they can read is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and that's all they know, the rote system. And what you are trying to tell us at this webinar is that we need to have a 360 degrees turnaround to use our cultural heritage,
Yes.
to make mathematics fun and enjoyable, but at the same time, achieving a better grade when we do the exams.
Yes.
Do we have any other question that our
And what
yes?
what I was going to suggest is that if there is if the school has determined that they are going to teach their students a particular language as well, then they could see how that language teacher can work together with the math teacher, so that they are teaching the language that relates to the mathematics that the student is learning.
You've just brought something that they do in the US. When I was a Fulbright student, teacher, One of the things is cooperative learning.
Learning.
I was teaching environmental science. Another person was teaching economics, and another person was teaching English. And the three of us worked together as a cooperative class teacher. So whatever I teach in environmental science, and Humara turns it into economics, French turns it into English. And so we now give them assignment, making use of that cooperative teaching method. And so you are now suggesting that whatever language teacher the schools have should work closely with the math teacher in the teaching of the language as well as the teaching of mathematics. Is that what you are suggesting?
Yes, yes. They can create lessons where the lesson has the math in the English form and is now converted to the language.
Well, again, that is having to work with the proprietor and
Yes.
proprietors as well as the local government in the schools for them to come to the realization of how to create an enabling environment to improve teaching in our schools and knowledge acquisition by our students. This is what I'm getting from you.
Yes, and it doesn't have to be a separate lesson that this is okay. We are going to learn about circles today, and this is math class. It could be a joint math and language class where, okay, we are learning about mathematics shapes. And when the math teacher has said that shape in English, the language teacher can say that shape in the language, and the students are learning the language, what that shape means.
Wow, you are really giving us some challenges at this webinar. And I still wish that Alaji Jimo from the Mathematical Association of Nigeria was here, because
I
they are
hope
policy people that can assist our group in getting this message across to the Lagos state government as well as to the private schools, where the teachers can begin to have interactive lesson classes where it is not memorization or rote, but fun classes, which is what you are preaching from this webinar. Mrs. Bello, is Alaji Dino back?
I hope we are recording the webinar.
Yes, ma'am. He tried to
Okay.
get in initially, but I just sent him the panelist link again, and I'm hoping he should join us any minute from now.
Okay. Well, since we have the recording, now we've grown to 34 of our participants, which is good, which means those who left us have come back, or we have new people that have joined us. And hopefully with the recording, they would be able at their own time to listen to what we have done today, because we want our maths teachers to enjoy teaching, while we want the students in the classes not to fear mathematics as a difficult subject, but see it as a fun subject. Because both you and I, from a young age, were able to see mathematics as a fun subject. So I hope that our 34 participants would be able to have access to the recording, and they can play back the recording and send us questions because they were invited to join, so they can use the Panabstract email questions that we can try to respond to. It's now almost 4:25.
I have questions for the participants.
Okay, please do.
Or not questions, rather, I would like to ask participants if there's any one of them that has ever used culture to teach mathematics, if they can share with us what they did.
Okay. Yeah, so participants, the question is to you. Can anybody share with us what methodology they have used in teaching of mathematics that is related to culture? Anybody? Please. The line is open for you to answer the question.
Or even if they have not done it, any ideas that have come to mind since listening to us.
Let me ask Miriam Adeyemi Modupe Ola. Please, can you, as a teacher in Nursery 2, can you share with us your thoughts of what you have listened to today? Miriam Adeyemi Modupe Ola, are you still with us? Okay, I think we've lost Miriam. Christiana Ogundare, you said nice explanation. Do you have anything you want to share with us?
Can I talk, ma?
Yes, please do.
Okay.
Miriam is back, Adeyemi. Let me
Yes.
mute myself so that.
Actually, good afternoon, ma. Good morning over there, ma. I really appreciate your lecture today, ma.
Thank you.
I really appreciate. I've learned a lot today. Actually, on the issue of relating it to the traditional, I've not been doing that. I've not been doing that. But I used to, at least I will explain to my students, not memorization. But personally, I don't enjoy memorization. I enjoy teaching my students for them to understand. Once they understand and they practice it a lot, I believe at least they'll be able to at least understand it better once they are able to practice it. Now, based on the issue of the traditional that you have taught us now, at least I've learned a lot today now. At least I realized that most of the topics in secondary, because I'm teaching in junior school before, but now I'm in senior schools. Most of the topics there, I don't know how we can relate it to the traditional. Most, especially like on set, you can still relate that set to traditional. But there are some other topics that I would advise if our lecturer can just know how, if you can work on the skill, on the curriculum, general, the Nigeria curriculum, this time around, so that if you can work on the Nigeria curriculum, so that if you can assist us to at least break it down to our level, that is number one. And number two, on the issue of the teachers, based on what you said, that we collaborate, yes, that we should collaborate. But I'm looking at how is it going to work with a lot of work that we have on our neck, especially the Lagos State teachers, from one period to another. If we are trying to collaborate in the class, how you hope is not going to affect the other next teacher that want to enter the class for the next period. I'm just thinking of all those things when you are giving us your lecture. That is the only thing I can say. Thank you very much. I really appreciate your lecture today, man.
Thank you. Professor Williams, you want to talk?
I taught science at the Methodist Girls High School between 1970 and 1975. And one of the things that I did was that I brought in Mrs. Osho, who was the maths teacher, Mrs. Agbaje, who was the Yoruba teacher, and Mrs. Williams, who was the English teacher. Well, luckily at that time, Miss Walker was a British woman who was the principal, and she understood what I was trying to do. Because you see, I left Nigeria after WAEC and went to Furabe, okay? And there, I did diploma in education, which meant I am a trained teacher. So when I came back to Nigeria, I was able to have what I called earlier as cooperative teaching, okay? During the holidays, all four of us would meet to look at the timetable. And what we did was make sure that the maths teacher, English teacher, Mrs. Williams, Mrs. Agbaje, the Yoruba teacher, and myself teaching science, we could work out our timetable whereby we walk to our different classrooms to meet our various activities. But as I said, as Mrs. Adeyemi has said, except your principal is in agreement with you, it will be difficult.
Yes.
Well, Miss Walker was in agreement because that was one of the years where one of my students went to Munich for the Olympic.
Welcome, sir.
Okay, Alaji Jimo, you are here. Wonderful. I will soon finish so that you can take.
Yes, at last.
Yeah. In that,
Okay.
I told her, she's now in California, that she cannot fail her WAEC. And she worked with us. But then also, the commissioner, Adenino Ogunsanya, was a very good commissioner. So I was able to go to him in his office at Broad Street in Lagos to explain what I was trying to do to improve the system whereby our students would make good grades for their WAEC. And so, Mrs. Adeyemi, I can understand what you are saying. Until we are able to get our schools and the inspectors and the various people to work with us to see what we want to achieve, it is difficult. Let me hand over to Alaji Jimo. Alaji, welcome. Over to you, sir. Alaji.
Enter as participants.
Alaji Jimo.
We can't hear you.
Oh boy, I think he's having problem. Anyway, let me bring up Oniyide Olugbenga. He said, carved wooden solid shapes, oranges for bearing and distances, using students to represent every principle involved in the teaching of variation. I agree with you. And then I thought significant tradition of giving importance to male child, even if the third born is a male child, he's still referred to as the Olori Edbi #1. For me, I disagree with Christiana on that because that does not make sense. A third child, because he's a boy, is Olori Ebi, does not make sense. Maybe I'm still coming from the gender perspective. The Olori Ebi would always be the first child, not the third child, because he's a boy. And then earlier, somebody also talked about something that both Professor Agu and I know. The Ifa is about numbers.
Yes.
That's the first computer that was ever created. And yet we do not appreciate that mathematical thing. Professor Agu already used Ayo as an example. These are computers. If we can see it from the mathematical perspective, and yes, if we can use them, we would be in a better place. Awodia Moses says, how do we teach mapping, binary operations, matrices, and determinants, etc., using traditional culture method? You talked about this when we were at the Mathematical Association meeting in Port Harcourt, Professor Agu.
Yes.
This is what Moses is asking. How do we teach mapping, binary operations, matrices, and determinants using traditional culture methods?
Yeah, you can teach matrices when you have because matrices is about simultaneous equations. So if you are able to create some type of simultaneous equation using your traditional artifact, John had five. John has five Manila, and Kate has 4 cowries, and together they are able to buy 11 pots, and then you create another simultaneous equation with the cowries, with the Manilas, and with the pots, and then they turn that into matrices, and they can solve the simultaneous equation using the matrix method and so on. And at the same time, you're reinforcing their traditional pride.
Professor Agu?
Yeah, I said, did they hear what I said? Normally, you will see simultaneous equations that have no relevance to anybody's life. And I'm saying, instead of simultaneous equations that have no relevance to anybody's life, like 3x plus 2y equal to 1 and 4x minus 3y equal to 0, that without x and y being given a relevance, you can make x something that is cultural, that the student understand, and y to represent something that's cultural that the student understands. And that is a simultaneous equation they have that is related to things that they understand in their culture, and they can now solve that simultaneous equation.
Well, I think Mariam has already given you a challenge. And I don't know how we will be able to get that across to you. To look at the curriculum for Lagos State and advise how the mathematics teacher can use cultural perspective, like IFA board, like IO board, like various effigies and things like that, to bring in the cultural perspective to make that curriculum more exciting and more teachable. I don't know how we can get that to you, because you cannot Google it. We have to go to the Ministry of Education to buy it and send it to you. That may be one of the challenges that PanAbstract and us have to answer one challenge that Miriam Adeyemi has given to us. And
I would prefer to pose it in a different format,
okay.
and that is, we have Alhaji,
Oh,
who used to be a member, and is still is, I think, even though he may be ex officio, member of the Mathematical Association of Nigeria. Such things are best done within the organizational context of these major stakeholders, who can now bring their consulting advice to the state education board, versus a singular person. And of course, yes, I would be more than happy to join them in their work in doing that, to give my own perspective, but it should be done a strategic, it is best accomplished in a strategic fashion that involves the stakeholders.
okay. Okay.
So maybe Alhaji could propose this to MAN as something that they may want to look at, and then maybe get a group within MAN, you get what I'm saying, and that also involves me, to work at it, and then bring it back and they propose it to the State Education Board.
Okay. Miriam Alo
Hello.
or Miriam Afo
Hello.
said that because,
Hello, great
yes,
mathematician.
Alaji, are you back? Okay,
The
great.
proper
Yes.
implementation of any curriculum depends on the quality of the teacher. Can I start?
Yes, please.
Mrs. Bello, please.
Alaji, please go ahead. You're welcome, sir. Alaji,
Great.
can you hear me?
Great mathematician.
Great.
Yes.
Yeah, great mathematician.
Great.
Great.
I'm very sorry, I've been battling with mine. I'm hearing. I can hear you. I can hear you. Can I proceed? One great mathematician. I want to thank our
Challenges of technology.
It's the network. The network has been poor. Like I was saying before Alaji joined us, Miriam Afo or Miriam Alo said, because I presently teach in a public school, I can relate with the use of our mother tongue to explain to the children. I believe when we explain to, when we teach using what they can relate with and what they think with, they will most likely understand better. So at least one of the participants is saying that because she works in a public school, she's able to use the vernacular to explain the difficult aspect of understanding mathematics in her class. So at least that's one person that has accepted that we could use our mother tongue to explain difficult things to our students. Adeyemi Miriam Modupe Ola said, yes, great. And then Awodia Moses says, great. Kafilat Majid said, great. So it's 4:45 and it's 10:42 at your end. At least we are now back to 35 on the webinar, which means that at least a number of the teachers have stayed on for more than 1 hour on the webinar. And those who have stayed on have been impressed with what you have presented today. We will see how we can continue to work with Panastrag to continue to try and encourage and empower our mathematics teachers in Nigeria. Mrs. Bello,
Yes.
let me
While
hand
he's
over to you.
talking, I think he assumes that we can hear him, but I don't know. I can't hear him from here. I don't know if you can hear him from your end.
I can't hear him.
Yes, and he's talking, so I think he assumes we can hear him, but I can hear him.
Can
So
anybody hear him?
I'm not sure.
I don't think so. Adeyemi said, I can't, ma.
Oh, sorry.
Taiwo Obe said, yes.
Hello, sir. We can't hear you. You are talking. We can't hear you at all. So I don't know. Can you hear? Can you speak up now, Alaji? Can you
Yeah,
hear
but
him?
faint. He needs to speak louder.
You need to speak up. Oof.
He's gone.
No, I called him. I made a normal call to him that we can't hear him. Sadly, still the same thing. I don't know what the problem is. Maybe it's from his own end.
Maybe he can speak into your call and you can put it to
From
the
here to project it.
yeah. Is
Let me
it
call him.
possible?
It's possible. It's just some tips.
Mm,
1 minute. Let me
It's
call
not
him.
possible.
Okay, at least we know this for the next time we have the webinar.
I can't hear you, but can you hear him? Can you talk now through this call and let's see if we can able to get some maybe just 10 minutes before we round up.
Okay.
teaching material. Let us look at teachers as users. The philosophy of mathematics helps teachers to determine goals of mathematics education. It helps teachers to study the content of mathematics education. It helps teachers to generate general organization of mathematics curriculum. It teaches the process of teaching and learning of mathematics. Of course, there are reasons why we review curriculum time to time. As we all know, changes. Because of changes in the user, changes in the world itself, changes in technology, changes in Nigerian society, especially with this COVID, the way we teach mathematics has changed throughout this period. We know how we communicate with our students. Changes in the understanding of how pupils and students learn. The way they learn mathematics is different from the way we were taught. Changes in international competitiveness. They want to go for Olympia, different Olympia. Now, what are the targets of the new mathematics curriculum courses? Please, I'm send out this slide something to everybody. The acquisition of mathematical and manipulative skills. Acquisition of skills for poverty reduction. Acquisition of knowledge and acquisition of ICT. Prof has said it all. Look at our surroundings. How can we apply physical things that we can see and relate to mathematics and to make teaching interesting? The empowerment of citizens to face national and global challenges. Acquisition of sufficient knowledge to pass exam examination. All these are targets for the new mathematics curriculum content. Let us take the role of mathematics as a subject. Mathematics as a research instrument. It is an instrument for national development in both the language and use of all sciences. Do you know that students do not understand the concept and why mathematical procedure works? The knowledge of mathematics other than to pass examination is a many of them look at it. We are the ones that bring it to them to know why mathematics is the curriculum. What are the objectives of mathematics? Mathematics used by people for making things work. The objective is preparing students. What are we teaching the subject for? Preparing the students for life after school. It is believed that students construct mathematical understanding and learn best when math is directly connected to their life. And that is why we have to make reality. In the culture that Prof has just said, we look around, see, we look at it, we give examples from what you can see. Forget about what example you have to be sent to. The reality, things they can see. If you agree with me, the objective of the new secondary education, mathematics, according to the basic, is to provide students with advanced basic knowledge and skills for entrepreneurship, wealth generation, and educational advancement. The second one is that it prepares the individual to be capable of independent thinking and to be able to appreciate dignity of labor. That is mathematics way. And the last one, which is the third, it provides the process for a child to develop, manipulate skills that will enable the student to function effectively in the society and to realize it or our full potential. So, ladies and gentlemen, we have got many of these. It's left for teachers knowledge. Make them things around them, bring it to their knowledge before teaching. Ask students questions to establish their entry behavior. Presentation of the lesson. The lesson be presented step by step. So that's my prof. Giving example from Anambra, giving example from areas that we can think of. For students to see and look at exactly what mathematics is, then the achievement of the stated goal. In conclusion, because of time, this is where the teacher is supposed to round up. That is our round up. The whole thing that has been said, and make sure we summarize. Go over it. Lesson. He established important facts in the lesson. He gives classwork within the knowledge of the student, and not for us to give. After giving a very simple example, you give them a difficult one. Like some of my students say, that teachers will always give us simple one and ask to become to bring the difficult one. We evaluate at every stage. Evaluation is not an end, but a means to an end. Not until they submit their paper before we evaluate. We use results. Teacher uses the results to improve on its own teaching. To find out that what to say, are they there? You remember our formulas, our if that we have been using for them to remember. For our formula. 5R circumference of circle.
5R squared is the area. 5R circumference of circle. 5R squared is the area.
Two-dimensional shape, plane shape. Let them identify different shapes, especially the essential one. Then before going, when they understand that they be able to draw each, after drawing, you now go with the you go with the properties. Then before introducing the formula for solving and what is expected of them. Triangle,
Rectangle, parallelogram, circle, square, rhombus, trapezium, plane shape. Pyramid, in a cylinder, and square, triboconal square. Shapes. Never forget solid shapes.
These are areas that we have put in for them to remember that all these you have mentioned are three-dimensional shapes. And I will never forget solid shapes. They should not go with the formula. You don't start with the formula, they will run away from the class. Or when they bring this with their mother teaching, they will remember. Ladies and gentlemen, also take your time. I will cut it off by reminding us of our mathematical aim.
Mathematics, I must pass my mathematics, I must get good grades in it.
All my
Subjects.
For others that are not mathematics teachers, not to take any offense to you. You look at it and say, okay, let them pass other subjects. Because the economic teacher they will say that, hey, it's the only mathematics teaching.
Subjects.
All my subjects, I must pass all my subjects. I must play grade in them. I love math. Math is one. Is there, is so. Is it not easy to read?
Yeah.
All you need to do is to pay attention. Then you will know that math is fun. Ladies and gentlemen, teach me, I forget. Involve me, I remember. So we must involve
Great. Bye-bye, sir. Thank you, sir. Yes, sir. Bye-bye, sir.
Thank you, Alaji. We are
Thank
happy
you.
that at least for the last 15 minutes of the 2 hours you've been with us, we appreciate you. And to all of our participants, we've now gone down to 29, but at least good statistics show that 80% of the participants have stayed for the 2 hours. So thank you all very much. Mrs. Bello, I hand over to you to close. Mrs. Bello. Hello,
Hello.
Mrs. Bello.
Hello.
Yeah.
Sorry about that. Once again, good afternoon, well, good evening for those of us in this part of the world. Good morning to others that are not here with us. I would like to say a very, very big thank you on behalf of Pan African Strategic and Policy Research Group, because this is one of our projects and it's been ongoing for quite a while now. We just did it fit not to let this year go by without us doing something. Like I said at the beginning of this webinar, it used to be a physical meeting in which people will come gather at our secretariat in Iju, and we do a lot of hands-on program as well where people learn a lot of things during the workshop. But this year we felt the need to come virtually to still remind everybody that, hey, we are still here. We thank God for COVID. It's come, it's still here with us. We are hoping that we will be able to survive this pandemic and live to tell a greater story. I also believe that for all of us that have been here all through from the beginning up till now, you probably should have learned one or two things that you'll be able to take to your classroom for those that are teachers, and for those that are not teachers that have younger siblings or children, we could also assist them in ensuring that we kind of revive the love for mathematics, because the general knowledge that we all know is that people tend to believe mathematics is difficult, is hard. So we are using this to continue to sensitize people that maths is fun, it's easy, it's something that we live with throughout the rest of our life. So I thank you all for joining us. And we will keep in touch because you're all registered. We have all your emails. So we'll keep in touch going forward so that many more of these that come up will get you involved as well. Thank you so much. Thank you.
Thank you.
Thank you.
Thank you, Prof. Thank you, Professor Williams.
Thank
Thank
you,
Professor Abby.
everyone. It
And
was my pleasure.
everybody a great end of 2020 and a fantastic start of 2021.
Amen.
Okay.
Amen.
Bye-bye.
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 Bye, everyone. Bye.
Bye.